Hi everyone. Today we're going to study fractions and types of fractions. A fraction is a part of a whole and written as a over b, where a and b are integers and b is not equal to 0. In a fraction a over b, the a is called numerator while b is called denominator. Here we have two examples. The first example is a circle that is divided into 8 equal parts, and 5 parts are shaded. So when we write this, the 5 shaded parts are written as 5 in the numerator over 8, and this 8 is the total parts of the whole. Another example is a square on the right side. The square is divided into 9 smaller squares, and 2 of the parts are shaded. So the fraction is written as 2 over 9. Now we will go to the types of fractions. The first type is what we call proper fraction. A proper fraction is a fraction whose numerator is less than the denominator. The examples given here are 5 over 6, 2 over 3 or 2/3, and 10 over 11. The next type of fractions is what we call improper fraction. An improper fraction is a fraction whose numerator is more than or equal to the denominator. Here we have examples: 7 over 6, 8 over 3, and 11 over 11. Another type of fraction is a mixed fraction, or sometimes called mixed number. A mixed fraction is a combination of a whole number and a proper fraction. Here we have examples. The first one is 2 and 5 over 6. Second example, 1 and 1/3. Third example, 7 and 2 over 11. The fourth type of fractions with respect to grouping is what we call like fractions. As defined, like fractions are 2 or more fractions having same denominator. The first example here, we have two fractions, 4 over 9 and 1 over 9. They have same denominator. Another example, here we have 4 fractions, all of them having 6 as the denominator. As we can see, the first one, 5 over 6, 1 over 6, 11 over 6, and the mixed number 5 and 2 over 6. Another group of fractions, we call them unlike fractions. Unlike fractions are 2 or more fractions having different denominators. Example, we have 2 fractions here grouped together, but they have different denominators: 4 over 9 and 1 over 7. Another group of fractions, we call them unlike. They have different denominators. The first one is 5 over 6. Second is 1 over 8. The third is a mixed number, 5 and 2 over 5. Hi everyone. Today we will study addition and subtraction of like fractions. As a rule, it says in adding or subtracting like fractions, meaning these are fractions of same denominator, we add or subtract the numerators and use the common denominator. We have a model here, a over c plus or minus b over c. This is equal to, we add or subtract the numerators, so this is a plus or minus b all over c. Let's see some examples. First example, 4 over 7 plus 1 over 7 equals 5 over 7. We simply added the 4 and 1 into 5, so 7 is the common denominator, so we simply copy that. The final answer, 5 over 7. Example 2, 9 over 20 minus 6 over 20. This time we subtract the numerators. 9 minus 6 equals 3. Then 20 is the common denominator. We simply copy that. Final answer is 3 over 20. For the third example, we have three fractions here, and there is a combination of plus and minus. So we have 10 over 21 minus 8 over 21 plus 3 over 21. So we copy the numerators, 10 minus 8 plus 3 all over the common denominator, 21. So we have 10 minus 8 will give us 2, 2 plus 3 will give us 5, and the 21 is here. So the final answer is 5 over 21. The fourth example is a whole number 2 minus 5 over 7. So this is subtraction of a whole number with a fraction. The rule says we should convert the whole number into equivalent fraction with same denominator. So how do we do that? We need to multiply the whole number with the denominator. So it's like this, the number 2, the whole number, we will multiply to the number 7. And then the answer here, we will write as the numerator of the equivalent fraction. And then we will copy the same denominator. That 7 here, we'll just copy here. So you see, the whole number 2 is equivalent to 14 over 7. So if we divide the 14 over 7, it will come back to the whole number 2. So now we have two fractions here that are like. So we can now operate them. So 14 minus 5 will give us 9, and the same denominator 7 is here. Or we can again put this into a mixed fraction. It is equal to 1 and 2 over 7. Let's go to the fifth example. We have 7 1/5 minus 2 and 3/5. So we can see here we are going to subtract two mixed fraction. So the rule says we must first convert the mixed fraction into improper fraction. So the 7 and 1/5 becomes 36 over 5. I assume that you know how to change this mixed fraction into improper fraction. See, this 2 and 3/5 becomes 13 over 5. So in this part, we have now two improper fractions, but they are like fractions. So we can now subtract the numerators. 36 minus 13 equals 23, and we copy the same denominator of 5. Then we'll just convert this again into a mixed fraction. It becomes 4 and 3 over 5. Thank you for watching. See you again next time. Hi everyone. Today we're going to study least common denominator. At first, let us define this least common denominator, or sometimes called LCD. This is actually the smallest number that can be a common denominator for a group of fractions. The next is, how can we find the LCD? We have three steps here. The step one is factor out respective denominators into prime factors. In case of repetition, we can combine using exponent. There is a note that prime numbers are numbers greater than 1 whose factors are 1 and itself. We have examples here: 2 as the smallest prime number, followed by 3, 5, 7, 11, 13, 17, so on and so forth. These numbers have factors, that is, only the number 1 and itself. The step 2 in finding the LCD is to list all the factors of respective denominators combined. For some common factors, copy the one with highest exponent only. And step 3, multiply all the factors listed from step 2 to get the LCD. Let's have an example. Find the LCD of the fractions 5 over 12 and 1 over 8. So the step 1 is, we're going to list the denominators 12 and 8 here. Then we will factor out these numbers. Initially, we may think of the factors of 12 to be 4 and 3, and the factors of 8 are 4 and 2. However, we know that this 4 is not a prime number, so we can still factor this number 4 into 2 and 2. So the prime factors of 12 are 2 times 2 times 3, while the prime factors of 8 are 2 times 2 times 2. Then we will combine these two into 1 by putting the power 2. Now the factors of 12 are 2 squared times 3. While for the 8, we have this 2 times 2 times 2 as factors. And to simplify this, we may write 2 cubed. So now, we will go to the step 2. In step 2, here are the prime factors of the two numbers. For step 2, we're going to copy all the factors. But in here, there is a common factor, and that is number 2. For the 12, it is 2 square. For the 8, it is 2 cube. So, we're only to copy the 2 cube. And then, these 3, we will include. So, we have now the factors 2 cube times 3. And the 2 cube can be simplified into 8 multiplied by 3, which is equal to 24. And this 24 is our LCD. Hi everyone. Today we're going to study addition and subtraction of unlike fractions, meaning these are fractions with different denominators. In this video, we're going to study two methods. The first one is the conventional method. The second is the crisscross method. Let's begin with the conventional method, where we are going to have 3 steps. The step 1 is to find the least common denominator. Step 2 is we convert each fraction into equivalent fraction having LCD as the denominator. And step 3, we add or subtract the equivalent and eventually like fractions. Let's see example 1. Add the following: 2 over 9 plus 1 over 6. Step 1 says, we find the LCD. First, we're going to list all the denominators here. Then take the prime factors of 9, that will be 3 times 3 or 3 square. The factors of 6 as 2 and 3. Then we're going to collect all the factors. I start with the number 2 and then the number 3. But there is number 3 with highest power, so I will copy the highest power as the rule says. Then we will simplify this 2 times 3 square, and that is equal to 18, and that is our LCD. Step 2 is we're going to convert the fractions into equivalent fractions having LCD as the denominator. Look at the 2 over 9. What we want to do is this number 9 to be equal to number 18. And we're going to multiply this number 9 with a number to get a product of 18. On the same way, this number 6, we want to make this 18 by multiplying by a certain value. As we see here, the 9 must be multiplied to 2 to get 18. The 6 must be multiplied to 3 to get 18. Then, that same number 2 that we multiplied to number 9 must be the numerator. So this must be 2 over 2 because this is equal to 1, and the number 1 multiplied to any fraction will not change the value of the fraction. The same way with the number 6 multiplied by 3, and then the numerator we must write 3 also. So the 3 over 3 that is equal to 1 is multiplied to 1 over 6. So the first fraction becomes 4 over 18. So we multiply 2 by 2 becomes 4. We multiply 9 by 2 becomes 18. The second fraction becomes 3 over 18. Because we multiply 1 by 3 becomes 3. 6 times 3 is 18. So now we have equivalent fractions here. Then in the step 3, we're going to add now the fractions. Eventually they are now like fractions. So the final answer is 7 over 18 because 4 plus 3 is 7, and then we copy the common denominator. Let's have the second example. Subtract the following fractions: 7 over 18 minus 1 over 12. So for step 1, we'll have all the denominators listed. Then we will factor out 18 into 2 times 9, and that 9 is equal to 3 square. We factored out 12 into 4 by 3, but the 4 can be written as 2 square. And then for the LCD, we list all the factors. For some common factors, we're going to write that factor with the highest power. So for number 2, 2 square is the highest. I will copy here 2 square. For number 3, 3 square is the highest power, so I'll copy the highest power, 3 square. And then we simplify this. This 2 square is 4, this 3 square is 9. We multiply 4 by 9 equals 36. So for step 2, we are now to convert the fractions into equivalent fractions. We want to convert this 18 into the LCD 36, so we multiply 18 by 2. So in here, it is 2 over 2. On the second fraction, the 12 must be multiplied by 3 so that it will get 36. So this fraction is 3 over 3. Then we simplify. The first fraction becomes 14 over 36 because 7 times 2 is 14. Of course, 18 times 2 is 36. Then minus. The second fraction becomes 3 over 36. Then step 3, we simply subtract 14 and 3 equals 11 over 36. Let's see this example number 3. This time we have 3 fractions here. 1 over 9 plus 2 over 15 minus 1 over 6. Step 1 says, let us find the LCD. 9, 15, and 6. The factors of 9 is 3 square. The prime factors for 15 is 3 and 5. The prime factor of 6 is 2 and 3. Then, for the LCD, we list all the factors here. I start with number 2, followed by 3. But since the highest power is 3 square, I wrote here 3 square. And then 5 is also listed. Then we simplify this into 90. So our LCD is 90. Now we're going to convert these fractions into equivalent fractions using the LCD of 90. So the 1 over 9, we multiply this 9 by 10 to get 90. This 15, we will multiply by 6 to get 90. This number 6, we will multiply by 15 to get 90. So the 10 here, there must be a 10 also in the numerator. Here 6 in the denominator, another 6 in the numerator. Here 15, another 15 in the numerator. So this one becomes 10 over 90. This fraction here becomes 12 over 90. This fraction here becomes 15 over 90. Then we go to step 3. We are now to operate all the numbers in the numerator. So the 10 is here, 12 is here, 15 is here. Of course, the signs or the operations here is plus. This is minus. All over 90. And we simplify all to be 7 over 90. Let us consider now this second method. We call this a crisscross method. So given a fraction a over b plus or minus c over d. The steps are, at first we're going to multiply a and d. So that is AD. Next, we put the sign. It can be plus or it can be minus depending on the operation. Then we multiply b and c. As you see here, it's BC. And then in the denominator here, the b and the d is multiplied and we put that as the denominator here. And the step 2, we need to reduce the fraction to lowest term if possible. So from our conventional method, this is the same example, 2 over 9 plus 1 over 6. We solved that in our previous example, and this is the answer, 7 over 18. So I'm going to put this answer on that side here, and then we're going to solve this using the crisscross method. So we multiply 2 by 6 becomes 12 plus, then we multiply 9 by 1 becomes 9. Then we multiply 9 by 6 becomes 54. We write in the denominator. And the sum is 21 over 54. Then we go to step 2. We will reduce the lowest term. We will think of a number that can divide both the numerator and the denominator. And we have the number 3. So we divide 21 by 3, we will get 7. We divide 54 by 3, we will get 18. As we see here, we have the same answer with the conventional method. Let's have another example. This is coming from the same example in the conventional method, the 7 over 18 minus 1 over 12. We solved that a while ago. The final answer is 11 over 36. So I'm going to put this 11 over 36 aside. We are going to solve this now using our crisscross method, and we expect to have the same answer here. I multiplied 7 and 12, I get 84, minus multiplying 18 by 1 is 18. Then multiply 18 and 12, I get 216. Then the difference on top is 66 over 216. Then we go to the step 2 to reduce this to lowest term. So the number 6 is the number that can divide both the numerator and denominator. So 66 divided by 6, I get 11. 216 divided by 6 is 36. And we have the same answer with our conventional method a while ago. Let's have this third example. So we have a mixed fraction plus a fraction plus a proper fraction. At first, we need to convert the mixed fraction to improper fraction. So this 1 and 2/3 is equal to 5/3. Then I copied the 1/4 here and the plus sign. Then I will start my crisscross method. 5 times 4 gives me 20 plus 3 times 1 is 3. Then 3 times 4 is 12. Simplifying the numerator, I got 23/12, or the mixed number of 1 and 11/12. Hi everyone, today we're going to study multiplication and division of fractions. Let's begin with multiplication of fractions. Given these two fractions here, a over b times c over d, the rule says we multiply the numerator by numerator and multiply the denominator by denominator. In this case, we multiply a to c and we multiply b to d. Let's have example 1. Find the product of 2/5 and 3/7. So we multiply 2 into 3 equals 6. We multiply 5 into 7 equals 35. Let's have the second example. Find the product of 4/9 times a whole number 2. We understand that the whole number has a denominator of 1. As you see here, the 2 becomes 2/1. Then we will proceed to the multiplication. 4 times 2 is 8. 9 times 1 equals 9. The third example is a mixed fraction multiplied by a fraction. So this is 2 and 1/5 times 2/3. At first, we need to convert this mixed fraction into improper fraction. So the 2 and 1/5 becomes 11/5. Then we copy the 2/3. Then we proceed to our multiplication. 11 times 2 is 22. 5 times 3 equals 15. Or we can put this into a mixed number, and this is equal to 1 and 7/15. Let's go now to division of fractions. Given this example, a over b divided by c over d. The rule says we need to invert the divisor and proceed to multiplication. So the c over d is our divisor here. We will invert. The d comes up as numerator, the c comes down as denominator. And then we will change the operation from division into multiplication. Now we will multiply a into d and b into c. Let's have example 1. Find the quotient of 2/5 divided by 3/7. At first, we're going to invert the 3/7 into 7/3. The division becomes multiplication. And then we proceed to multiplying. 2 times 7 is 14. 5 times 3 equals 15. Another example is 3 divided by 2/5. A whole number divided by a fraction. So we are showing here the 3 becomes 3/1. Then the division becomes multiplication. The 2 over 5 becomes 5 over 2. So this one becomes 15 over 2. Or this is equal to 7 and 1/2. Hi everyone. Today we're going to study how to simplify complex fractions. At first, let us define what complex fraction is. A complex fraction is a fraction with fraction in the numerator or in the denominator or both. Examples are 2/3 over 5, 6 over the fraction 7 over 10, and the last example 1/2 over 4/5. Now, let us simplify complex fractions. At first, let us understand the general form, and that is A over B, that there is a fraction in the A, or B can be a fraction, or both are fractions. Please note also that fraction denotes division. So the A over B can be written as A divided by B. Now let us see some examples. Let us consider the first example, 2/3 over 5. So we can write this 2/3 over 5 into 2 over 3 divided by 5. Next, the number 5, the whole number, can be written as a fraction with denominator of 1. Then we follow our rule. We're going to invert the divisor. The 5 over 1 becomes 1 over 5. Then we proceed to our multiplication. So 2 times 1 is 2. 3 times 5 is 15. So 2 over 15 is our final answer. Let's have the second example. 1/2 over 4/5. Let us write this again into 1/2 divided by 4/5. So the 4/5 is now inverted into 5 over 4, and then we will proceed to multiplication. So 1 times 5 is 5, 2 times 4 is 8. 5 over 8 is our final answer. Let us have one challenging question. This 1/3 minus 2 over 7 all over 1/4 plus 2/3. Our idea is the whole numerator can be written as one group here, then divided by everything in the denominator is also placed as another group, and then we have two big groups here that we can simplify one by one. So for the first group, I'm going to use the crisscross method to solve this. So this is 1 multiplied by 7 gives me 7, and then 3 multiplied by 2 gives 6. Of course, the sign is subtraction. So this is 7 minus 6, and then 3 times 7 is 21. Then divided by, for the second group, we also use the crisscross method. 1 times 3 is 3. 4 times 2 is 8. So this is addition. So I put the plus sign. Then 4 times 3 is 12. Then let us simplify. The 7 minus 6 is now 1 over 21. We just copy that 1. We just copy the 21. Then 3 plus 8 is 11. We copy the 12 down here. So now our problem is now a proper fraction divided by another proper fraction. So we're going to invert our divisor. 12 comes up, 11 comes down. The operation becomes multiplication. Then we'll just multiply and we will get our final answer. So 1 times 12 is 12. 21 times 11 is 231. So 12 over 231 is our final answer. Let's have our last example for this video. So there is a whole number 2 up here, and at the bottom it's like a complexity of fractions. So when we have a problem like this, what we will do is we're going to start the simplification from the bottom going up. So this is 3 minus 1/2. First, we're going to convert the whole number into equivalent fraction. So the whole number 3, we're going to change into equivalent fraction. The rule is here. We multiply that whole number to the denominator of the other fraction and use as numerator. So this is 3 times 2 is 6, and we use the same denominator 2. So 6 over 2, that is the equivalent fraction for the whole number 3, and then minus the same 1/2 is here. So we can see the 6 over 2, if we simplify this, it will come back to that whole number 3. Now, let us simplify this part. The 6 over 2 minus 1/2, we can write it to be 5 over 2. Now we're going to simplify this 2 up here is a whole number, at the bottom is a fraction. And we can write it like this. The whole number 2 multiplied by, so this is division, the 5 over 2, it flips up. The denominator 2 comes up as numerator, divided by 5, or 2 over 5. So we can multiply now the 2 and the 2, it gives us 4 over 5. So we have now here 1, the whole number 1, plus the proper fraction 4 over 5. Now we're going to consider this whole number 1, make it another equivalent fraction. So I'm going to multiply this 1 into this 5. My answer is 5, and I'll write it here. And then using the same denominator 5, I copied here. So you see, 5 over 5 is the same with that whole number 1. So we can simplify this addition of fraction here. 5 over 5 plus 4 over 5. We will get 9 over 5. Next is, we're going to flip the 9 over 5 into 5 over 9. And we have this multiplication. So 2 times 5 gives us now the final answer, 10 over 9. Or the mixed fraction 1 and 1 over 9. Thank you for watching. Watch out for more math videos. Please comment, subscribe, like, and share this video. See you next time. you.